Welcome to lesson 77, real problems with quadratics. So for all those who are like, when do I use this in real life? Here's some real situations. So here's our CFS. So you're going to watch how we can use the table of values in our graphing calculators to identify the key features. That's going to be the big point of our parabola, the key moments in the experiment, so to speak. And we're going to relate the vertex as the highest point, or when the object in our situations reaches the highest point in the air. And then we're going to relate the zeros as the point where it comes back to Earth, where it hits the ground. Okay? And we're going to relate the y-intercept as the initial height of the object. So wherever we start from, because it may not be from zero. Like I might see a question where I'm standing on a tree or I'm at the top of a building. So that's our initial point. So we're going to be when our time is at 0, x is at 0, what is our y? That's going to tell us our elevation. And then we're going to represent the domain of the parabola using an inequality symbol. So let's jump in. And here's something, I already have this in your notes, and just some things to keep in mind. And it's pretty much everything that we just said in the CFS. Is identifying when the object is on the ground, and that is when the height, or y, is 0. So in a lot of our situations, whatever our y value, this will represent our height. And our x represents time, which is always moving forward. Now, our second tip is to know that when it reaches a maximum height, that's our vertex. So at some point, what goes up must come down. Basic principle in physics. It doesn't just stay in the air. Whatever goes up eventually comes back down because of gravity. And in these situations, that's what we're going to look at. I'm sure if you take physics, you can find tons of situations that will show things still staying in the air. I get it. Please, we're just going to talk about normal things going up and back down, not balloons and drones and things like that. And tip 3, we're going to input the quadratic equation into the graphing calculator, and that's how we're going to find the tables to do this real work, because that's our goal, not to figure out everything by hand. Okay, so that's what we're looking for. The start is our first point is when t equals 0. Are we starting from the ground, or are we starting from high up? Like whatever our y is in that initial point, when x is 0, that y is going to tell us where we are height-wise. Then something's going to go up and something's going to go down in our story. So the vertex is going to be that turning point, where it's at its highest point, and then when it's back down on the ground. So let's look at this one first. A ball is thrown from the ground, so that's great. That means we're starting at 0, 0. And the height of the ball, we want to know is height above the ground at t seconds after it's thrown, can be modeled by the equation -16t squared plus 64t. After how many seconds from being thrown will it hit the ground again? So that's what we want to find. So in our story, we're going to start here at 0, 0. We're going to throw a ball, and this is what we want to know. We want to know the when. When does this happen? When and that's going to be when our y is back at 0. What is our x at that point? All right, so we're going to use our calculator for this. So let me set up decimals so we can get those points. So now that we have all our points, here we go. This was everything from decimals. This is the only thing that you're literally inputting into your table. You're just taking the points that we have there and just putting them in. But here's the thing. We definitely do not care about when time is negative. Not important. So we're going to start with our initial, and we're just inputting our other coordinates. Perfect. And I'm going to just annotate so that we have this in here. This is our initial point, the start. And it's at when we were at the ground, that's that 0, 0. Here is our vertex. And it's when our y was at its highest point. So that's here, 264. So that's at 2 seconds. And then here was the ending when it hit the ground again. And that was at 4 seconds. So that's what you're looking for as you're getting these points from the table on decimals, and literally you're just taking them and inputting them into your table. But the context matters, and so being able to identify the start, which in this case was at when you were at 0 on the ground, 0, 0, time was at 0, you were at the ground, threw the ball in the air, this was the highest point, and this is when it hit the ground again. And that's what we wanted to know, how many seconds before it hit the ground, after being thrown will it hit the ground. So let's put that in. We never actually answered that. The ball hits the ground at 4 seconds. And done. That's it. So hit pause and jot this down into your notes. All right, let's try one on your own for guided practice. I'm just gonna read through and identify some of the notes I'm annotating, and then you're gonna hit pause and start solving. The ball is projected up in the air from the surface platform of a platform to the ground. So that's important. I want to name that. You're on a platform to the ground. The height of the ball above the ground in feet is modeled by the function right here. T is time in seconds after the ball is projected. State the height of the platform in feet. So that's the first thing they're asking us to do. What is the height of the platform? Then 2, we're going to state the coordinates of the vertex. And we have to explain what it means. And then finally state the entire interval for which the ball's height is decreasing. All right, open up those graphing calculators, hit pause, and jot this down onto your notes, and we'll go over answers in the spoiler reveal. Here are the answers. So number 1, state the height of the platform. And our platform is at 112 feet. For the vertex, it is 3 to 56, and that represents the maximum height of the ball. And then here's our interval, where between 3 and 7 seconds, so I've written it down as 3 is less than x is less than 7. So check this off. If you have this, you can continue on to your checkpoint. And if you're unsure, then stay on. Let's get some context and try to understand what's happening and try to figure out where we're not aligned right now. So let's tell some stories first. Here's our chart, right? And so we're standing at a platform, so we're somewhere above ground because it tells us we're on a platform, so we're above. And we're throwing a ball in the air, and we want to know when it hits the ground. So the first part we're looking for is the height when t is 0. So we're looking for that number, h, let's put it this way, 0h, because at that point time is at 0, but you're high up in the air. Your height is higher than 0. So that's the first thing you're going to look for. Then the second part of our story was our vertex, so we're going to look for that turning point in our data. And then we're going to look for when the ball is on the ground, and that's going to be when what is time when y is now at 0. So we're going to look for that. And then finally, we're going to try and figure out what is that measure of time between, let's kind of highlight it. What is the time between here and here? What is that difference in time? Okay. All right, so the first thing you probably would have done is you should have picked up your graphing calculator. That's my first go-to because this isn't written in an easy form, but you can find zeros if you wanted to. But I found, let's just go and get our graphing calculators out. Okay, and if you did that, you can get your table of points. Here they are. And let's go into context. Again, this is time to height in feet. Time was in seconds. I don't care about time before the start, so getting rid of that. So here's the first thing you're looking for. When time is at 0, notice our height is at 112. So there it is, 0, 112. That's what we were looking for in the beginning. Then we wanted to identify that turning point. So you were looking to see when does that change, and we see this is increasing, and then after here is decreasing. So this is our second major number, which is the first one. So this is important in the story. That's our vertex. And that's the highest point of the ball. And then we wanted to find again when the ball hit the ground, and that was when our y went back down to 0. So that was at 7, 0. And we needed that because we wanted to know when it would stop decreasing. So we knew that from here to here, our ball is going up. So from 3 to 7 seconds, it was going up, 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 and then at 3 seconds, it started going down. So that interval from 3 to 7, we want to jot down. That's what I'm expressing here. So I wrote it as an inequality, and I've also written it just in simple words. And that's it, Math Marbles. That's what you need. Again, we're just building context. So I find that pictures really help. So if map out, what's the story? What's the story of what's happening? Usually it's a ball or something being projected in the air and going back down. So start with the story.